Hello and welcome to the video lectures on development of lateral surfaces. Now, this is a solid, so that is a pentagonal prism. What is the meaning of development? Development means all these lateral surfaces we are going to lay it down into the two-dimensional surface. Now, the principle of this is all the lines which are present on the development should be the true length of that line which is there on the surface. For example, if you take this prism and if you lay it down to the two-dimensional surface, the three-dimensional solid will be laid to the two-dimensional. So, the prism looks like this. So, this is a pentagonal prism. So, there are 5 rectangular faces you can see here. So, that is why pentagon. If it is a square, then we have the 4 rectangles like this. So, that is what the development means. Similarly, if you take a pyramid, so this is a pentagonal pyramid, and if you lay down the lateral surfaces to the two-dimensional, the pyramid looks like this. So, this is the development of a pentagonal pyramid. Now, here all these lines, that is the slant edges, should be of the true line. So, that is the main principle of the development. Then what is the use of development? Now, these developments are mainly used for the sheet metal work, that is for manufacturing of various sheet metal components, then the pressure vessels or various types of ducts, then connecting one rectangular pipe to a circular pipe or like that, the transition piece we call. So, this is actually a very important chapter having very good practical applications in the industries, that is the process industries or chemical industries or in refineries. We have the pipelines and all those. In that, the development concept is very much required. Now, this development can be done in various methods. So, there are 4 methods are there. One is called as the parallel line method, which is used for the development of prism and cylinder. And the second one is called as radial line method, which is used for development of pyramid and cone. And third one is called as the triangulation method, which is used for the transition pieces, and the last one is the approximate method, which is generally used for the spheres. Now, we will glance all this briefly, then in detail you have to go for the first 2 methods. The remaining 2 methods are generally not used in the academic syllabus. So, that is why. Parallel line method. Now, in this parallel line method, so we are going to draw parallel lines like this. The lateral surfaces are represented by number of parallel lines. So, that is why it is called as a parallel line method. So, in detail we will discuss later. Then second one is the radial line. Radial line means the lines which are produced from single point like this. Number of lines are drawn. So, it may be used for the development of pyramids or development of cone. So, that is why it is called as the radial line method. It may be used for the pyramids and cone. Then transition piece. Transition piece means it is a component which we are going to use it for connecting a circular pipe to a square duct, that is transition from circular part to the square. So, the one part will be the square and the other side will be a circle like this. So, this is called as a transition piece. So, to connect one circular pipe, at the other side we have the square duct. If you want to connect it, that connecting piece, so that is called as a transition piece. Now, the transition piece we are going to develop by using the principle of triangle. That means, we are going to draw small triangles like this, number of triangles, and finally, we are going to get the development of this. Next method is the approximate method. Normally, it is used for the sphere. Actually, the sphere cannot be developed. So, that is why it is approximately we are going to make. So, that is why it is called as approximate method. Normally, if you see the football, in that we have the small stitches like this. So, for making the spheres, we have to make the small segments like this, and finally, you have to bend it and you have to connect it. Then it becomes the sphere. So, that is why this method is called as approximate method, so which is used for the sphere or spherical objects. Now, we will go for the development of prism. we take the example of a pentagonal prism of 30 mm side. So, we have to draw the pentagonal prism top view and front view. So, this is the pentagon of 30 mm sides. Then you have to draw the front view of this, project it up, then draw the front view. And give the naming of this. This is A, B, C, D and E. Similarly, this is A dash, B dash, C dash, D dash and E dash, and the base, this is A1 dash, this is B1 dash, C1 dash, D1 dash and E1 dash. Height of this is 60 mm. You mark that dimension also here. Then for making the development of this, you extend a light line like this from the base. Similarly, from the top, you extend one line. Then leave some space and drop a vertical line like this. Then measure this, that is the base side 30 mm, and keep it here 5 because it is a pentagon, 5 times. If it is hexagon, then 6 offsets will be there. Then afterwards, from all these points, you have to drop the verticals. Like this. Then dark this base and top. So, this is the development of a pentagonal prism. Normally, it is named in the capital letters. Naming of the development will be done with the capital letters. All these edges you have to name it. This is A1, B1, C1, D1, E1, and at the end once again the starting point will come, because these 2 points will connect together when, if you take this example, now this is the edge A, and if you are opening from A, so the A will come here as well as here. So, that is why both the ends, this is also A, this is also A, but while combining it becomes a single point. So, that is why it is A1 and A. Similarly, here the top surface you have to name it as A, B, C, D, E, and once again A. Generally, in the projection of solids, we are going to use the lowercase letters, but for the development, we are going to use the capital letters for the naming of this. So, this is the development of a complete prism. Now, we have to go for the pyramids. Pyramids. Take the example of a pentagonal pyramid. A pentagonal pyramid of 30 mm side and height 60 mm. A pentagonal pyramid of 30 mm side. So, make the pentagon of 30 mm base, edge. Then mark the center of this. For marking the center, already you know the midpoint of this will be joined to the opposite corner, connected by a light line. Midpoint of one more side, this side, I will connect it to this, and the intersection of these 2 lines, that will be the midpoint. Then afterwards remove all those lines. So, this is the midpoint of the pentagon. Then draw the front view of this. From the midpoint, project this midpoint and then draw the axis. The height which is given here 60 mm. So, draw that axis and complete the front view of the pyramid like this. Then give the names. This is A, B, C, D and E, and connect all these edges in the top view. The slant edges, you have to connect it like this because it is a pyramid. And name the front view also. This is O dash, this is A dash, B dash, C dash, D dash and E dash. Now, in case of pyramid, in the development, you have to use the true length only. Now, if you see all the slant edges here, that is OA, OB and OC. Out of this, only OC is the actual length. This is the true length. Remaining all are the apparent length. Only the slant edge which is parallel to VP is the true length in the front view. Now, if you see in the top view here, OC, that is here, this particular line is parallel to XY line. That means it is parallel to VP. That is why the length of this OC will be the actual length in the front view. So, this length you have to take it for the development. Remaining all these slant edges, they are the apparent length. So, we cannot use it for the development. Now, to start with the development, so draw a line like this, and length of this will be exactly equal to OC, not the other edges. These two are the shorter, so that is why you have to take OC only. Why it is OC means this is parallel to VP. So, that will be the actual length. So, take this actual length and keep it here. So, you have to draw one line. Then upwards, take the compass with this as the center, draw a light arc. Then take the compass and measure this 30 mm, the base edge, and from this particular point, mark here 1, 2, 3, 4, 5 like this. 5 offset. If it is a hexagon, then it will be 6. Then connect this point here, then connect like this. So, one triangle part is over. Similarly, draw the next radial line and connect it here. Then remove that arc part here also. Then the third segment, you connect here and draw the straight line and remove the arc. Then fourth one, you connect it like this, and the last point. Then name it. So, this is A, B, C, D, E and A. So, this is the development of a pentagonal pyramid. If it is hexagonal pyramid, then one more segment of the triangle will come. So, that is how the pyramids are drawn. Development of a cone. You take the example, a cone of diameter 50 mm and height 60 mm. So, the top view and front view is written here. Now, in this case, so this is called as the generator. So, I denote it by the capital letter R. Now, if you open a cone, then it becomes a sector like this with an included angle of theta, and this will be the length of the generator. Now, to find this theta, what is this theta? So, from the geometry, the sector length, that is from A to B, what is the sector length? So, that we can find by using the formula R into theta. So, sector length AB is equal to this R into theta. That means r into theta. So, that is why theta is equal to sector AB divided by the capital R, that is a generator. Now, this sector length, that is from here to here, that is nothing but the circumference of this, which is equal to 2 pi r. If you substitute like this, 2 pi r divided by capital R, so reframe it. So, we will get theta is equal to r by r into, instead of 2 phi, you write as 360 degree. It becomes r by r into 360, where capital R, that is the generator length, we can find it by from the geometry by using the Pythagoras relation. Capital R is equal to under the square root r square is the base radius, plus h squared, where h is the height of the given cone. And if you substitute here, so we will get the value of theta equal to r divided by under the square root r square plus h squared into 360. So, here you have to substitute the value of r and height, then we will get some value for the theta. Theta we are going to obtain it. That is the first step for the development of the cone. Then after getting that theta value, draw a line, the length equal to the length of the generator, then mark whatever the calculated value of theta here, then draw the arc. So, that is what the development for the cone. Now, we will go for the development of a cylinder. Development of a cylinder. So, in the cylinder, the front view, this is the top view of the cylinder, and this is the front view of the cylinder. Now, in case of cylinder, we are going to use the parallel line method for the development. So, from here you draw a line, then from this you draw one line and leave some space and drop a vertical line, and from here you measure the length, that is the circumference of this, from this particular point up to here. So, this length is equal to the circumference pi into d. So, this is the development for the cylinder. Its length will be pi into d, and this part you have to make it dark. It becomes a rectangular piece like this. This is the height of the cylinder, the given height, and this will be the circumference, the base circumference, that is equal to pi into d. So, till now we have discussed about the various types of solids. Now, we will go for the examples. Actually, in the development we are going for the sections instead of making the development of the complete solid. So, we go for the section. Section means a part of that solid will be cut and it is removed. The remaining part of the solid we have to make the development. So, take one example, a pentagonal pyramid of 30 mm edges of base and height 50 mm rest vertically with one of its base edges parallel to VP and nearer to it. It is cut as shown in the figure. Draw the development of the upper portion of the pyramids. Now, here the pentagon has been drawn, so that one of the base edge is parallel to VP and nearer to it, so like this. Then we have to draw the front view of this. All the edges A, B, C, D, they are projected, then they are connected, all the slant edges. Now, this is the section plane which is inclined at an angle of 30 degree and passes through this corner, that is also drawn. Then if you see here the slant edges, that is OA, OB, OC, OD and OE. None of the slant edge is parallel to VP. That means all these slant edges what we are represented here, they are not the true lengths. So, true length is available only when the slant edge is parallel to VP. Now, if you see here the top view of the slant edges, so all these lines are not parallel to the XY line. So, that is why true length is not available. So, for this first you have to construct the true length. For that this is the procedure. Take any one of the slant edge and rotate it to the horizontal. Draw a horizontal line like this, light horizontal line from O. Then take the compass and take this length O to C. Then draw a arc like this. It will meet here. From here you have to drop a vertical line up to the XY line. From here you have to drop a light vertical line up to XY line. So, this is the XY line. Then this particular point you have to connect it to O. This point will be connected like this, and this is the true length of the slant edge. Now, here the section points are there. Whenever the cutting plane cuts a slant edge, then we will get one section point. Now, here the section points are, you have to number it in the sequence. The section plane which cuts OA, so that is I call it as 1, section point 1, and the section plane which cuts the BO, that means the section point 2 will be here, and 3 is here, section point 4 is for DO, DO is cut here, so this is 4, and section point 5 is for EO, EO is cut here. So, this is the fifth one. Now, all these section points, that is 1, 2, 3, 4, 5, what you are marked here, you have to transfer it to the true length. You have to transfer it to the true length just by drawing parallel lines like this. Here you have to draw one parallel line like this, then from 5 one more parallel line, from 2, from 4, and this is 3 like this. Then afterwards you have to mark, this is 1, this is for 5, this is for 2, this is for 4, and this will be 3. All these points which are on the slant edges, you have to transfer it to the true length diagram. Now, you have to go for the development of this. For the development, take this true length in the compass, not any other generator, from here to here. This true length you have to take it and draw one arc, then draw a line from this point like this. Then take the base edge, that is 30 mm, then cut it here, then one more like that, 5 times you have to cut, it is a pentagon. Then afterwards connect it like this, then draw this. Similarly, connect this point and draw here. Then the other line you have to draw it like this. So, this is the development of the complete pyramid. Actually, it is the section one. So, you have to mark the section points. So, for that marking, you have to give the names. This is A, B, C, D, E, and A. Now, the section point 1, it is on AO. For marking that, take the compass and on the true length diagram, don't measure this, you measure it on the true length diagram, this distance, and keep it here on OA. This is point 1. Once again repeat the same, because OE is here also, the same point what you have marked here, you have to mark it here. Then section point 2, it is on BO. 2 is from here to here, this is section point 2. From O up to here, like this. This is point 2. Then 3 is on CO. 3 is directly here, 3. And 4, you measure this and it is on DO. This is the point 4. And 5 is on EO. Measure this and mark like this. This is 5. Now you have to connect all these points, that is 1, 2, 3, 4, 5 with straight line segments. 1, 3, 4, 5 and once again connect it to the 1. And here the bottom part is removed, so that only the top part is retained. So that is why the bottom part of this should be made light. So this part will be light and the top part will be retained as a dark, like this. So this is the required development for the sectioned part, like this. So you make it dark, all these edges also you have to make it dark. If the bottom part is retained and the top part is removed, then you have to darken the remaining part, and this portion you have to keep it as a light line. So this is about the development of a sectioned pyramid. Now we will go for one more problem on cone. Draw the development of a cone of diameter 50 mm and height 60 mm, and it is cut to the section plane as shown here. The front view is given in the problem itself. They have given this front view. They have cut it like this, and they have also cut it like this. And this diameter they have given it as 15 mm. Here the diameter is 15 mm from here to here. And this angle they are given it as 30 degree. And height of this is 60 mm. First you have to draw the circle of diameter 50 mm, then divide that circle into 8 equal parts. We can use the angle method and divide it into 8 segments. Then draw the front view, complete front view. Then from this point you draw a line at 30 degree so that you can get one section plane here. Then upwards they are not given this height, but simply they have mentioned that this diameter from here to here, this diameter is 15. So that is why you have to use the trial and error method to locate this particular point. That means you have to move the scale parallel to the base so that at certain location you will get this distance as 15. So at that location you draw a horizontal line like this, a horizontal line. Then you complete like this. This is the part which is retained, so you have to draw the development. Now for this you have to calculate the value of theta. So theta equal to r by r into 360. Theta is equal to r divided by r into 360, where small r is 25 because the diameter is 50, so small r will be 25, and capital R equal to under the square root 25 square plus the 60 square, the height. So that becomes the angle is 138 degrees, 138 degree. After that you draw a line length equal to capital R, that is this length generator, and dry arc with this radius. And from here you measure the angle of 138.4 and draw one more line. So, this angle will be 138.4 degrees. So, this is the development of the complete cone. Now, here actually it is a sectioned one. There is a section plane which is inclined at an angle of 30 degree. So, for getting the section points, we have to produce all these points upward, project it upward like this, so that we will get number of generators and give the name for this A, B, C, D, E, F, G and H. Similarly, here it is A dash, B dash, C dash, D dash, E dash, F dash, G dash and H dash. Then connect all these points to the apex O by a light line. It is not the dark line now. This becomes the light line. All the generators you have to draw it here. Like this. Now we have the section points on this section plane. For each generator there will be one section point. For AO there will be one point, that is point number 1 will be exactly here. For BO there is one point, that is on BO, this will be point number 2. For CO there will be point, so this is point number 3, and for DO this is DO, so that is why this particular point will be the point 4, and on EO it is the point 5. So, this is the 5th section point. And for FO, the 6th one, it will coincide with the 4th one. So, that is I will write as 6 inside the bracket, because if you observe it from here, that point 6 cannot be visible. Similarly, 7 is on GO, so that comes here. This point itself is the 7, and 8th one it is on HO, so it is here. So, these are the section points. Now, here the generator, that is OE or AO, these two are the true length of the generator. The intermediate generators, they are not the true length. That means the section points 2, 3, 4, they are not on the true length, but 5 and 1 they are on the true length. So, that is why all these section points, that is 2, 3, 4, all these you have to project it onto the true length generator, either to this or to this. I will project it like this. Draw a line parallel to the XY line onto this, then mark the points here on the true length. So, this becomes 4 and 6, and this becomes 3 and 7, and this is for 2 and 8. One is already on the true length. Then after that, the angle what you have drawn, that is 138 degree, you have to divide it into 8 equal parts, 138 divided by 8. So, divide it into 8 segments, equal segments like this. Like this. Then give the names for all this using the capital letters A, B, C, D, E, F, G, H, and the last one once again it is A, and this will be O. Now, you have to mark all the section points. The section point 1, it is exactly here. This is 1. 1 will be repeating here once again. This is 1. Take the compass and from O you measure this distance O to 2 or 8. Measure this and mark it on BO. On BO here, mark it this distance and call this as 2. Similarly, same point will be there here because 8 is also same distance, 8 is on HO. So, mark this also 8. Now, you measure 3 this distance O to 3 or O to 7. For 3 and 7 the same distance, take it, and it is on C this distance, and similarly on G the same distance. So, this becomes the point number 7, this becomes the point number 3, and measure this distance O to 4 or O to 6, keep it on DO, this is the point 4, and on FO it is the point number 6. Now, you measure this O to 5 and keep it on EO like this. This is the point number 5. Now, you have to join all these points by a smooth curve. It is not a straight line, since it is a cone. You have to connect all these points with the smooth curve, all 1, 2, 3, 4, 5, 6, 7, 8. Then finally connect it to 1 like this. So, this section plane part is over now. Then there is one more section part, and since this section plane it is horizontal or parallel to the base, then marking the section points are not necessary because all these section points will have the same radius. So, that is why take the compass and measure this distance on the true length of the generator from O up to here, not on the remaining generators. In this generator you measure this and take that distance in the compass, keep this as the center and draw a arc like this. This is the radius I had taken from here to here on the true length, and I have drawn this. Then you have to darken, this part is removed, so that is why it will be light, and the retained portion should be dark. That means this will be dark and the base part will be light, and this curve what you have drawn, you have to make it dark, and this edge also is dark. This is also dark. So, this is how the development of this particular cone, that is the partial cone, a part is removed from the base, a part is removed from the top. So, that is how the remaining part will be like this.